According to the National Electrical Code, specifically Section 312.6 subsection A, electrical equipment, which includes panel boards, must be installed at a minimum height of 18 inches above the floor or working platform. However, there is an exception to this rule. Equipment operating at 30 volts or less can be installed closer to the floor or platform. Furthermore, Section 312.6 subsection B dictates that the top of the panel board must not exceed 6 feet 7 inches above the floor or working platform. These height restrictions are important for accessibility and safety, ensuring that electricians and other qualified personnel can easily and safely access the panel for maintenance, repairs, and inspections. When it comes to outdoor panels, the National Electrical Code does not explicitly provide specific height requirements that are exclusive to them. This means that the general requirements outlined in Section 312.6 still apply. However, it is essential to recognize that local building codes may impose additional or more stringent requirements for outdoor electrical panel installations. These local codes often take into account factors such as weather conditions, potential hazards, and accessibility for utility workers. Utility companies may also have their own specific requirements for the height of electrical panels, particularly in relation to the placement of the meter. It is imperative to contact your local utility company to ascertain whether they have any specific regulations or guidelines that must be followed. Their requirements may be based on their own operational needs, safety standards, and local conditions. To ensure compliance with all applicable codes, regulations, and utility requirements, it is recommended to install the panel between 18 inches and 6 feet 7 inches above the ground or working platform. This range satisfies both the National Electrical Code requirements and any potential requirements from your local utility company. Ignoring height restrictions can lead to several problems. Firstly, it can result in non-compliance with electrical codes and regulations, leading to potential fines, penalties, or rejection of the installation during inspection. Secondly, improper panel height can create safety hazards, making it difficult or dangerous for electricians and homeowners to access the panel for maintenance or in emergency situations. Thirdly, it can impede accessibility for individuals with disabilities, violating accessibility standards and regulations. Always check local building codes because these codes are adapted from the NEC or written as amendments that supersede the NEC. Check the adopted year of the NEC because each county and state differs. An example of a local code variance could involve grounding requirements, conduit fill, wire types allowed for certain conditions, and specific inspections required. It is always best to check with the local authority having jurisdiction prior to starting any electrical work. When planning an electrical installation, it is important to have all the facts before you begin. You should also make sure that you have the correct permits prior to beginning work. Permit requirements can also vary by location, so you must know what is required in the area in which you are working. You should also have the correct tools and safety equipment. You should follow lockout-tagout procedures when working on any electrical equipment. Double check that the power is off using a calibrated meter and follow proper personal protective equipment standards. The correct personal protective equipment includes safety glasses, gloves, and appropriate clothing to prevent electrical shock. You should also make sure that you have a clear and unobstructed work area. This means removing any tripping hazards and ensuring that there is adequate lighting. The panel should be mounted to a sturdy surface that will not vibrate or move over time. Before connecting any wires, be sure to properly size all circuit breakers and conductors to match the load demands and in compliance with the National Electrical Code. Overloading circuits is a dangerous condition that can lead to overheating and fire. Label all circuits clearly and accurately. This will help prevent confusion and make it easier to identify circuits in the future. Tighten all connections properly. Loose connections can cause arcing, overheating, and potential fires. Use a torque wrench to ensure that all connections are tightened to the manufacturer's specifications. Use appropriately sized and rated wire connectors for all splices and terminations. Wire nuts, terminal blocks, and other connectors should be rated for the voltage and amperage of the circuit. Protect all wiring from physical damage by using conduit, cable trays, or other protective measures. Exposed wiring can be easily damaged, leading to electrical hazards. Keep the panel clean and free from debris. Dust, dirt, and other contaminants can accumulate inside the panel and cause overheating or short circuits. Inspect the panel regularly for any signs of damage such as cracks, corrosion, or loose connections. Address any issues promptly to prevent further damage or hazards. If you are not comfortable working with electricity, hire a qualified electrician to perform the installation. Electricity can be dangerous, and it is always best to err on the side of caution. Understanding the National Electrical Code is a process that can take many years to master. Here are some additional considerations to keep in mind with electrical installations. Firstly, consider the environment where the electrical panel is installed. In wet or damp locations, use a panel that is rated for outdoor use and ensure that all connections are properly sealed to prevent moisture from entering. Secondly, think about future expansion. Choose a panel with enough spare capacity to accommodate future electrical needs. This will save you the hassle of having to replace the panel later on. Thirdly, be mindful of accessibility. Ensure that the panel is located in a place that is easily accessible for maintenance and repairs. Avoid placing it behind obstructions or in hard-to-reach areas. Fourthly, ensure proper grounding. Grounding is essential for safety and helps to prevent electrical shock. Make sure that the panel is properly grounded to a grounding electrode system. Fifthly, use the correct type of wiring. Use the appropriate type and size of wiring for the application. Factors to consider include the amperage rating, voltage rating, and environmental conditions. Sixthly, protect against overcurrent. Use circuit breakers or fuses to protect circuits from overcurrent. Ensure that the overcurrent protection devices are properly sized for the circuit. Seventhly, consider surge protection. Install surge protection devices to protect sensitive electronic equipment from voltage surges. Surges can damage or destroy electronic devices. Eighthly, label all components. Clearly label all circuit breakers, switches, and other components in the panel. This will make it easier to identify and troubleshoot problems. Ninthly, inspect regularly. Regularly inspect the electrical panel and wiring for any signs of damage or wear. Address any issues promptly to prevent further problems. Tenthly, follow manufacturer's instructions. Always follow the manufacturer's instructions for installation, operation, and maintenance of electrical equipment. This will help to ensure safety and proper operation. Proper labeling is an important step in any electrical installation. Firstly, clearly label each circuit breaker with the area or appliance it controls. For example, you might label breaker kitchen lights or living room outlets. Secondly, use a permanent marker or label maker to create clear and legible labels. Avoid using handwritten labels that can fade or become illegible over time. Thirdly, attach the labels securely to the circuit breakers or panel door. Use adhesive labels or label holders that are designed for electrical panels. Fourthly, create a panel directory that lists all of the circuits and their corresponding labels. This directory can be placed inside the panel door or kept in a nearby location. Fifthly, update the labels whenever changes are made to the electrical system. For example, if you add a new circuit, be sure to add it to the panel directory and label the corresponding circuit breaker. Sixthly, use color-coded labels to differentiate between different types of circuits. For example, you might use blue labels for lighting circuits and red labels for appliance circuits. Seventhly, use symbols or icons to indicate the function of each circuit. For example, you might use a light bulb symbol for lighting circuits and an outlet symbol for appliance circuits. Eighthly, label all switches, outlets, and other electrical devices with their voltage and amperage ratings. This will help to prevent overloading circuits and ensure that the devices are properly matched to the electrical system. Ninthly, label all grounding and bonding conductors with their size and type. This will help to ensure that the grounding system is properly installed and maintained. Tenthly, label all conduit and cable runs with their voltage and amperage ratings. This will help to prevent accidental contact with live wires and ensure that the electrical system is properly protected. It is also essential to ensure proper grounding of the electrical system. Firstly, connect all metal enclosures, such as electrical panels, junction boxes, and equipment housings to the grounding system. This will help to prevent electrical shock if a fault occurs. Secondly, use a grounding electrode system that is appropriate for the site conditions. This may include grounding rods, ground plates, or underground metallic water pipes. Thirdly, ensure that the grounding electrode system is properly bonded to the building's structural steel or concrete reinforcing bars. This will help to create a low impedance path for fault current to flow back to the source. Fourthly, use grounding conductors that are sized according to the National Electrical Code. The size of the grounding conductor depends on the size of the circuit conductors. Fifthly, install ground fault circuit interrupters in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Ground fault circuit interrupters can detect small amounts of leakage current and quickly shut off the power to prevent shock. Sixthly, test the grounding system regularly to ensure that it is working properly. This can be done using a ground impedance tester or a ground fault loop impedance tester. Seventhly, keep the grounding system free from corrosion and damage. Corrosion can increase the resistance of the grounding system and reduce its effectiveness. Eighthly, use anti-seize compound on all grounding connections to prevent corrosion. Anti-seize compound can help to keep the connections clean and prevent them from seizing up over time. Ninthly, protect the grounding system from physical damage. The grounding system should be protected from being struck by vehicles, equipment, or other objects. Tenthly, follow the manufacturer's instructions for installation and maintenance of grounding equipment. This will help to ensure that the grounding system is properly installed and maintained. When you are selecting and installing circuit breakers, there are several important factors to keep in mind. Firstly, choose the correct amperage rating for the circuit. The amperage rating of the circuit breaker should match the amperage rating of the circuit conductors and the appliances or equipment that will be connected to the circuit. Secondly, select a circuit breaker that is compatible with the electrical panel. Circuit breakers are designed to fit specific types of electrical panels. Be sure to choose a circuit breaker that is compatible with the panel. Thirdly, use circuit breakers that are listed by a recognized testing laboratory such as Underwriters Laboratories or Canadian Standards Association. Listed circuit breakers have been tested and certified to meet safety standards. Fourthly, install circuit breakers in a dry location. Circuit breakers should not be installed in damp or wet locations, as this can lead to corrosion and electrical shock. Fifthly, protect circuit breakers from physical damage. Circuit breakers should be protected from being struck by vehicles, equipment, or other objects. Sixthly, label circuit breakers clearly with the area or appliance they control. This will make it easier to identify and troubleshoot problems. Seventhly, test circuit breakers regularly to ensure that they are working properly. Circuit breakers can be tested using a circuit breaker tester. Eighthly, replace circuit breakers that are damaged or defective. Damaged or defective circuit breakers can be a fire hazard. Ninthly, follow the manufacturer's instructions for installation and maintenance of circuit breakers. This will help to ensure that the circuit breakers are properly installed and maintained. Tenthly, use arc fault circuit interrupters to protect circuits from arc faults. Arc faults are a common cause of electrical fires. Arc fault circuit interrupters can detect arc faults and quickly shut off the power to prevent a fire. Another important area to keep in mind is conduit fill. Firstly, determine the correct conduit size for the number and size of conductors you will be installing. The National Electrical Code specifies the maximum number of conductors that can be installed in a given size of conduit. Secondly, use conduit fill tables to determine the maximum number of conductors that can be installed in a given size of conduit. Conduit fill tables are available in the National Electrical Code and in electrical handbooks. Thirdly, do not exceed the maximum conduit fill. Overfilling a conduit can damage the conductors and make it difficult to pull them through the conduit. Fourthly, use the correct type of conduit for the application. There are different types of conduit available, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit. Choose the type of conduit that is appropriate for the application. Fifthly, support conduit properly. Conduit should be supported at intervals specified in the National Electrical Code. This will help to prevent the conduit from sagging or bending. Sixthly, use conduit fittings that are compatible with the conduit. There are different types of conduit fittings available, such as couplings, connectors, and elbows. Choose the fittings that are compatible with the conduit. Seventhly, ream the ends of conduit after cutting it. This will remove any burrs or sharp edges that could damage the conductors. Eighthly, use a lubricant when pulling conductors through conduit. This will help to reduce friction and make it easier to pull the conductors through the conduit. Ninthly, seal the ends of conduit to prevent moisture from entering. Moisture can damage the conductors and lead to corrosion. Tenthly, follow the manufacturer's instructions for installation and maintenance of conduit. This will help to ensure that the conduit is properly installed and maintained. Always refer to the latest edition of the National Electrical Code and local building codes for specific requirements and regulations regarding electrical installations. These codes and regulations are constantly evolving to ensure safety and prevent electrical hazards. Remember, if you are unsure about any aspect of electrical work, it is always best to consult with a qualified and licensed electrician. They have the knowledge and experience to perform the work safely and correctly.